This is the second session for NTP. We are going to talk about some NTP basic definitions: authoritative time, authoritative source, authoritative device, stratum, master server, root delay, and root dispersion. Let's talk first about the authoritative time. The authoritative time is what we consider to be the correct time. It is given in UTC. We actually want our devices to synchronize with this authoritative time. The authoritative time comes from an authoritative source. Authoritative sources may be a GPS system or atomic clocks. Authoritative sources are reachable through what we call authoritative devices. Authoritative devices are devices that are connected to authoritative sources. So for instance, we can have servers or network devices that are directly connected, for instance, to atomic clocks or to the GPS system. Just a note here, if you're using too many authoritative devices, this may bring instability in time synchronization if they happen to disagree on the current time. Just a note here, if you Google authoritative time sources or NTP servers, you will find a list of publicly available IP addresses of NTP servers that you can use in order to synchronize your local area network with. Let's talk now about another NTP definition, which is stratum. The stratum indicates how many hops exist from the current device to the authoritative time source. So by that definition, the authoritative time source itself will have zero stratum because it needs 0 hops in order to reach itself. Now, the authoritative device, which is the server or network device that is connected to the authoritative source, will have an stratum of 1 because it only needs 1 hop in order to reach the authoritative source. Let's say this device here is using this authoritative device as its NTP server. Then this device here will have an stratum of 2 because it needs 2 hops in order to reach the authoritative time source. And let's say this device here is using this other device as its NTP server. So this distribution switch will have an stratum of 3 because it will need 3 hops in order to reach the authoritative time source. Now, CISCO devices are not designed to become public stratum 1 devices. They are not designed to get connected to the GPS system or to atomic clocks. However, if within your local area network you don't have access to a public stratum 1 device, you can turn your CISCO device into an authoritative device for your local area network if you issue the command NTP master. Then your device will use its local hardware clock as the authoritative source for your local area network. Let's talk now about the root delay. The root delay is an NTP measurement that will provide you with the round trip time between any given device and the authoritative source. Let's describe how this process works in order to calculate the root delay. Let's place ourselves first at the stratum 1 device. The stratum 1 device is going to calculate the round trip time in order to reach the authoritative source. In the case of atomic clocks, this value is going to be almost 0. In the case of GPS systems, this value may be larger. We are going to call this calculation the peer delay. And in the case of the stratum 1 device, the root delay will be the same as the peer delay. Now, the root delay that was calculated here at the stratum 1 is going to be sent to all its clients. So stratum 2 devices are going to be aware of this calculation because they are going to receive them through NTP packets. Now let's see how to calculate the root delay at an stratum 2 device. Let's place ourselves here at an STRATUM 2 device. The STRATUM 2 device is going to calculate the round trip time between itself and its NTP server, and it is going to call that the peer delay. And in order to calculate the root delay at the STRATUM 2 device, we are going to add the root delay that we are receiving through NTP packets plus this peer delay that we just calculated. Now remember that these peer delay calculations are made through the timestamps that are exchanged with NTP messages between client and server. Now let's talk about root dispersion. With root dispersion, we are going to measure the clock time difference between the local clock and the authoritative source. In order to calculate the root dispersion at each stratum, we are going to have to calculate something that is known as peer dispersion between stratums. This peer dispersion calculation uses a more complex formula than the one that we use for peer delay. Now let's talk about how the root dispersion process works. It is pretty similar to what we saw with root delay. Every single stratum is going to calculate first a peer dispersion value with the previous stratum, and then it is going to use this peer dispersion value in order to calculate a new root dispersion value at that stratum. Now, the root dispersion value may change over time when devices are still synchronizing or recently synchronizing with a new authoritative time source. This value may be high initially, but will eventually get a lower. And it is never going to be zero, because that will be an ideal case. Devices will never have the exact same time as the authoritative time source.